Okay. Logarithmic functions as inverses. Can you get some paper out, please? Really? You've sat here this whole time without a pencil? I already gave pencils out to other people. There's paper in the basket if you need paper. Okay, logarithmic functions as inverses. Who's heard of a logarithm? It looks like log. Have you done logs before? Not like a log that you throw in a fire, different type of log. But log is the abbreviation for logarithm. Okay, so this is probably new for almost everyone. I can't hear you. What? I think it's like our third set of notes. Because we did exponential for 2 days, remember? We did 2 sets of notes on one, we combined them. So this was probably like the second then. Okay, so our essential question today is what does, oh, not what does, sorry. What is the definition of a logarithmic function? What is the definition of a logarithmic function? And how does a log is just the abbreviation for logarithmic, relate to the function y equals 10 to the x? Oh, that is not a straight line. Let's try that again. Oh, did it erase? Y equals 10 to the x. Question mark. What is the definition of a logarithmic function, and how does a log relate to the function y equals 10 to the x? Okay. To start, the definition of a logarithmic equation, the definition of a logarithmic equation is the following. Now write this part nice and large with lots of space, because it's kind of like the golden formula of all the notes. So you'll want to like put a big box around it so you can see it. If you have highlighters, this would be something you would highlight. X equals b to the y, which is interchangeable with log base b. Okay, this b is like a subscript. It's lower. The x is the same height as the log, equals y. So this b is like a subscript. It should be a little bit lower. Okay, the one on the left is called exponential form, which makes sense because it has an exponent. Okay, this one on the left, leave about a line of space. Skip a line and then put exponential form, because we're going to add something on the definition. Exponential form Leave about a line of space before you write exponential form. The one on the right is exponential form, but it's been converted to logarithmic form. Okay, so to convert back and forth, it's actually really easy. We call it the circle of logs, like the circle of life. Lion King days, remember that song? The circle of life. Oh, I should make a song about the circle of logs. That would be fun. It was like, no. All right, it's really quite easy, but the thing you have to find is you always have to start at the base. Okay, B represents the base. If you notice, both have a base. The exponential form has a B, raising an exponent. Isn't the thing holding up the exponent called the base? The number or the variable that would be holding up the exponent is always called the base. You agree? Yeah? That one we've heard of before. Well, log form also has a base, and it's going to be the same number. That B right there is also the base. So we always start at the base, and we always cross over to sides. Okay, so if we take exponential form and turn it into logarithmic form, we're going to draw a circle. It goes log base B of x equals y. Okay, starting at the B, and you're always crossing sides. Log base B of x equals y. Okay, there's a nice little pattern. Well, why don't you guys go close that door? I don't know what they're listening to, but it's a little distracting. Same if we start in not their door. It's not their door, our door. Thank you. Okay, same with logarithmic form. If we start in logarithmic form and we need to convert over to exponential form, we find the base and cross sides. So here's the base. To change to exponential form, we're going to have an exponent. Chips. Base B raised to the y equals x. Always starting with the base, crossing over. Base B to the y equals x. That would change us into exponential form. And we can go back and forth, and we'll practice that today, going back and forth. Just one sec. Yeah. Just. Well, it'll be a log base 2 of 1 equals y. Yeah. Okay. All right. So we're going to try a couple switching. Why isn't this expanding? There we go. Example 1, switching between forms. Okay, we have 100 equals 10 squared, which is a true statement. Do you agree that 10 squared is 100? Yeah. Okay. We're going to take 100 equals 10 squared, which is exponential form, and we're going to convert it to logarithmic form. Okay. But first, we have to identify the base. So please find the base and put the base up in the air with your fingers. What's the base? What's the base? Find the base and put the base up in the air. What's the base that's holding up the exponent? Find the base and put it up in the air. Notice I always do the wrong one. Good, 10, right? So that's where we start. So circle of logs time. 10, it's going to be log base 10. It's still going to have the same base, and the 10 will be lower. So it's a subscript. Log base 10 of, what do we go to next? Crossing over. Good. Of 100 equals what? 2. So we always cross side to side. Equals 2. This is logarithmic form. If it's asking you to convert into log form, yeah, that would be the answer. Just remember we have to start at the base and we always cross. So cross over to the other side of the equal sign. Log base 10 of 100 equals 2. And the exponent is by itself. Okay? Let's try another one. Example 2. 81 equals 3 to the 4th. 81 equals 3 to the 4th. This is exponential form because it has an exponent and there's no logs. Logarithmic form has a log written, so it's easy to tell. Find the base, please. Put it up in the air. What's the base? Find the base, please. Put it up in the air. What's the base? The base would be holding, up the exponent. What's the base? D, what's the base? What's the base? 3. Good. That's where we start our cycle. Okay, what's the first thing we write over here? Log, and we'll put base 3, okay, of, what number do I go to next? 81. Log base 3 of 81 equals, excellent. Excellent. Okay, let's practice actually saying this, though. You don't just say log 381. Okay, the proper way to say it is log base 3 of 81 equals 4. Okay, so everyone say it with me, please. Log base 3 of 81 equals 4. Just like this, right here, you don't say, some people say like 3, 4, or I've heard weird things with exponents. You either have to say 3 to the 4th power, or if it was like a square, you say 3 squared. But you could also say 3 to the 2nd power. With exponents, you have to have the phrase to the. Here we have to say base and of. Log base 3 of 81. Okay? Right, I'm going to give you a more challenging one, and I'd like you to try it by yourself. Let's see if I can get this to move. There we go. But I think you can handle it. Example 3. 8/27 equals 2/3 cubed. Change that, please, to logarithmic form. 8/27 equals 2/3 cubed. Always identify the base first. It looks scary, but it's the same process. Identify the base first. Make sure you cross sides. After you have the base, cross the sides. Good. 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 Excellent. That's not too bad, right? Okay, Eric, what did you write? Good. Uh-huh. What do you think? He even used the right words, right? He said base and of in the right positions. Log base 2/3 of 8/27 equals 3. Excellent job. Okay, I think I'm going to give you guys an extra one I didn't give yesterday because they were on short schedule. I'm going to give you another curveball. See if you can figure it out. See if you can figure it out. Let's see. Let me make sure this works, though. Okay, let's do this. Every problem we've done so far always had the exponent on the right. I'm going to put it on the left, see if you guys can still do it. Okay, change it to logarithmic form. Even though I've switched the side where the exponent normally is, you can still do it. The key is always start with the base and switch sides when you're drawing the cycle. You should always be switching sides. Okay, start with the base and switch sides. Good. Good. Mm-hmm. Mm-hmm. Yep, you have to find the base. Start with the base and then switch sides.
Alright.
Good. Okay. Macon, can you tell me please, what was the base that you started with? 4. Okay, let's see how she did. Macon? What do we think? Good, because she's switching sides, right? And she said it perfect with the base and the of. Log base 4 of 124 equals 5. Excellent. Is that good? Okay, now we're going to go reverse. I'm going to start with logarithmic form. And the directions for this is, what is the value of each logarithm? The same directions you'll have on your homework. What is the value of each logarithm? What is the value of each logarithm? Same directions you'll see on your homework. Okay. Log base 8 of 32. Log base 8 of 32. Do you notice it doesn't have an equal sign? Okay. There's going to be a process of steps in order to evaluate this. So, just for your information, look on your calculator. Do you see a log button on your calculator?
Yeah, I see it.
Log. Okay, but log, actually, if you look above it in blue, it says 10 to the x. Because they're inverses. So one of your essential questions was, how does a logarithm relate to the function y equals 10 to the x? And look on your calculator. It has 10 to the x in blue right above it. I'm going to draw a picture really quick. You don't have to draw it, because I'm going to erase it. So our growth, like 10 to the x, is a growth because the base is greater than 1. If the base is greater than 1, it creates a growth. Looks like this, right? So this is a growth with a rough sketch of what it would look like. What a logarithm is the inverse. Inverses are reflected over this dotted line, y equals x. Okay? If you remember how we solved for inverse functions, the first step was to replace f of x with, do you remember? Replace f of x with y. The second step was to literally switch. What did we switch? We did this when we were facing that board, when the smart board was not working. First step, switch f of x, change it to y. Then you switch the values of x and y, right? And then you solve for y. So you're literally taking the x and the y's and switching the places, which means all the points. Say this point was, I don't know, 1, 3. Well, there's going to be a point on the reflection. I'm not very good at drawing those, but we'll pretend that that's the reflection. Called 3, 1. Oops, well, obviously it should be higher because, let's try that again. I didn't do a very good job drawing that. There we go. 3, 1. There'd be a reverse point where the x and the y literally have switched places. And the reflection over this diagonal line is where we get the logs. However, our calculator only has the ability to do a log base 10. Okay, most of our counting systems are in base 10, right? We have 10 fingers, and we don't get to the next place value until we've hit a 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 are all single digits, and once we hit the 10, then we're in double digits. Our clock is not base 10. What's our clock? Base 12, right? It doesn't start over until we've hit the 12, and then it goes back to 1, and that's a base 12. Okay, so most of what we do is base 10, probably because we were born with 10 fingers. Okay, so it was convenient. So logarithms on our calculator can only handle a base 10. So next lesson, we will learn how to fix that if we need to calculate something that's not a base 10. Right, so the first step in order to find the value of this log is to fix what Stiles was saying. It's not an equation. So let's make an equation. Okay, the first step is to write as a, I'm just going to put log, it's abbreviation for logarithmic equation. Okay, we want to evaluate it, so we need an unknown value, which would be x, right? Because we don't know the value of it yet. So by making it equal x, it's now an equation. Second step is to convert, which we should be able to do now. Convert to the other form. What's the other form called? Exponential form, because our calculator can't handle a base 8. Okay, convert to exponential form. Our calculator can do exponents of any number we want. Okay, so let's calculate it to convert it to exponential form. I want you guys to try that. Find the base. You always start at the base. Find the base, cross sides, and convert it to exponential form. Okay, you don't need a calculator. Just draw the cycle. Find the base and draw the circle of logs and convert it to exponential form. So exponential form will no longer have a log, and it will have an exponent instead. Alright guys, what's the base? The base is 8. So if we cross sides, it would be 8 to the x. So you have to cross. 8 to the x. I think you had the 32. Right? Equals 32. So that big number by the log is always the exponent. Or, sorry, I said that wrong. Is always the, by itself. Yeah. I was just confusing myself for a minute. Okay, now who knows what 8 to the x, what value of x would make it 32? 8 to what power equals 32? Because if we knew that, would be done. We know x. 8 to what power equals 32? 8 to the 4th power? That means 8 times 8 times 8 times 8. I think that might be a little too large, don't you think? 8 to the 4th power. 4,096. Okay? 8 to the 1st power equals what? 8. 8 to the 2nd power equals what? 64. 64 is too big already. So our answer for x is somewhere in between 1 and 2. Is it 1.5? I don't know. Let's see. Here's how we can figure it out. Okay, next step is to write each side in simplest common base. Because if the bases were equal, then the exponents would also be equal. But right now, we have bases 8 and 32. What's the smallest common factor both of those have? 8 and 32. What? 2. So when you're writing, doing this step, it's generally a really small number, such as 2 is 4, 3. 2 to what power equals 8? How many 2's does it take? 2 times 2 is 4. It takes 3 2's, right? So that would be 2 cubed. But don't forget, we also have it to an x power. Okay, how many 2's does it take to get to 32? 2 times 2 is 4, times 2 is 8, times 2 is how much? 8 times 2 is how much? 16 times another 2 is 32. So how many 2's did it take to get to 32? 5. So that would be 2 to the 5th power. Now look, they have a common base. Okay, next step, step 4, is to apply the power rule. Right here we have two exponents. An exponent raised to another exponent. Remember your exponent properties? What happens when we have an exponent raised to another exponent? Do we add those? Forrest, do you remember what we do with those two? Subtracts when we're dividing, adding's when we're timesing, multiply. When we have a double exponent, we multiply those. So this is really 2 to the 3x equals 2 to the 5 to the 5th. Since the bases are equal, it means the exponents are equal. So solve it. Since the bases are equal, it means that the exponents, 3x, is equal to 5. So find the value of x, which is actually the value of our original logarithm. Is it 1.5?
Yeah.
Nope, that's not. Find the value of x. Solve for x. Yep, 1.6 repeating, or the fraction, if we divide by 3, 5/3, which is 1.6 repeating. Okay, so our answer to log base 8 of 32 is 5/3. Or you can put 1.6 repeating. As long as you put the repeating bar, that's fine. You can even write 1 and 2/3. Any questions? How we got to that point? There are 5 on your homework that you follow those exact same steps. The trick is to get them to a common base, so that if the bases are equal, then the exponents are equal. Okay, let me explain your homework. Would everyone open your books, please, to page 332, so you can visually see what we're doing for homework. Open books, please, to page 332. Page 332. We're doing all of 32, which includes, you see how there's 2 got it's, and there's an A, B, and C with both those got it's? You're doing A, B, and C on problem 1's got it, number 1 and 2, and then you do problem 2's got it, it's A, B, and C. So the entire page. Does that make sense? Book, Anna? Good, okay. And then on the next page, all you have to do is number 3 and 4. Page, including the got-its, and numbers 3 and 4 on the next page. So, I don't know how to write that clearly, but 332 through 333, you're doing the got-its for 1 and 2 with the A, B's, and C's, and numbers 1 through 4. Okay, so once you get to that blue box, you stop. Okay, so right here in purple is your homework. Here.